Nish and Matt are here to teach us how to build our first microservices with .NET. So I'm going to let them take it away because they are definitely the experts here.
All right. Nish, how are you doing this morning?
Very well. How are you?
I'm
Not morning, evening for me.
It's evening for you and morning for me, right? We are
Yeah.
worldwide. So we're going to talk about building your first microservice with .NET. Super cool topic, and we're really excited about it. And much like John and Myra did before, this is a Learn Live module. And so, Nish, you and I put together this module earlier this summer, and
Yep.
we're not going to have a lot of time for everybody to follow along with it. We're going to really kind of compress it, but when folks want to actually sit back and do it themselves, they can go to akams.net-conf-microservice so you can do everything that we're going to show you how to do today. So part of what we're going to cover today is explain what microservices are, and how you can cover or what the various technology are involved in microservices are and how they all relate, because there's a ton of different terms that people throw around when we're talking about microservices, and we're going to explain what they are and how they all interact. And then we're going to build one. Nish, we are going to build a microservice using .NET. And of
Absolutely.
course, it's live and interactive. Nish and we want to answer some questions for you about what microservices are, how they interact in .NET, the whole ecosystem. So say hi, ask questions, let us have it. And Nish, how about we kick it off and you tell us what microservices are?
Absolutely. Well, microservices, also known as microservice architecture, is an architecture style that states that you compose your application as collection of smaller services. And when we talk about smaller services, it's not about taking the application and splitting that down into multiple web API projects or something like that. But it's more importantly to understand the business domain and then create services with specific business boundaries. And often, patterns like domain-driven design is used to do that. But today, what we're going to focus on is just about building the microservices endpoint in .NET, and then we'll see how to containerize it and go on. So, Matt, let's speak more about microservice architecture.
Sure, absolutely. So microservice architecture really is a huge, huge topic, but let's break it down a little bit the best that we can. So each microservice itself has a separate code base. So you can think of each microservice really as like its separate application, which is nice because then it can be managed by its own small development team. So way back in the day, Nish, I mean, we're used to dealing
Mhm.
with these huge, huge monolithic
Monolithic?
applications.
Yeah.
Yeah. Do you remember when we used to have like 50 projects all shoved into a solution that did like one thing? And like
Yeah.
it
A-
was,
Yeah, and if you wanted to make a change to one of that, you need to complete the integrations and other kind of tests to make sure that you can ship that bug even to the production.
yep. And so it was one team and everybody had to know everything. But microservices, they're small, they're
Yep.
independent, and they are loosely coupled, which is nice because then you can Nish, if you're working on your development team, cool. You take care of
Yeah.
what you have to do. I take care of what I have to do, and loosely
Yeah, that's
coupled.
right. So when in monolithic times, like you basically have modules in the application. So you might have an order or payments or customers in case of e-commerce domain, for example. But when you start to put together as a deployable unit, they're all packaged inside. But in microservices, even though you split in business domains, you're technically having business boundaries, and it is managed by independent team, and most importantly, because they are split by business domains, they are loosely coupled. So you can go ahead and change one without affecting the other.
And that brings us right to our next point is that when you do change one and don't affect the others, you can
Yep.
deploy one without taking down the entire application, which is a big deal because if you think like in the US, we have the big shopping days coming up, like Cyber Monday. And a lot of times, like if something happens, like your caching service goes down or something, you don't want to have to take down the entire app because you're going to lose money. And so with microservices, you don't have to do that. You can just take down something that is going wrong, redeploy it, and not have to take down everything. And now I'm always talking like the worst case scenario, like something's breaking and going down. But just like in regular day-to-day life, there's no need to take down an application. And what's nice is that some people, your users, might not even know about the app going down because they might not be using that particular portion at the same time when you're deploying it.
Right.
And another really cool thing about microservices, and this is a thing that took me a while to get my mind wrapped around, is that each one essentially has its own database, which is, Nish, this one really took me a while, and help me out here.
Yeah.
Why do they have their own database?
Yeah, so I think this is a crucial point about microservices. When I spoke about monolithic and having modules and having deployable in it, we always had a large monolithic database, and that often becomes the bottleneck for any kind of changes that you want to do, or even for performance reasons, right? So, so when you split this out, when you have independent teams managing individual services, it's very important to even have the database separated. And that's when you have that database separated, that's when you have that complete, independence and autonomy to go ahead and make changes to those features and or fix bugs in production without really affecting on the other service, right? And what this also means is that, how does then two services work with each other? How does it connect to find out the data from the other services? Which brings us to our next point, which is
That they don't care how things are implemented internally,
yeah,
right? As long as you have a well-defined API for a microservice, as long as microservice A knows how to communicate with microservice B, it doesn't care how it does its work inside. I mean, the database could, as far as microservice A goes, the database for B could be a file. It doesn't care. It doesn't care
yeah,
how it's implemented. It could, microservice A could be .NET, microservice B can be Java. So you can have different polyglot programming going on where the teams are specialized. They know how to do their work. They're comfortable in their lanes, so to speak. As long as the APIs are well defined, we're good to go. So that's pretty neat. Just the different programming styles where it kind of differs from our monolithic days where everything had to be one language, one framework. Now it's whatever does the job best.
right.
So,
And if you bring up the next point as well there.
oh,
So there's the polyglot programming that you mentioned. I think the important aspect here again is to look at choosing the database of choice, right? I mean, some services, maybe it's all right to use the SQL server. Maybe some services you would need NoSQL. So that choice is based on the services and teams. It's not like a large choice that is made by a large team and making those decisions, right? And also, I know we talk about having one service running on Node.js and the other service running on Java and then .NET. They all can work together. Well, that's true, but I think that's going to be very expensive to implement. But I think the important aspect here to understand is it's possible, especially when you, for example, if you have legacy systems and things like that, when you already have systems that you cannot move, then you can still keep that in that service and then move the other things around and then still work together, right? So that's the important aspect there.
yeah, that's really, and it's really neat to work with, especially the whole legacy system upgrade. So, Nish, a lot of times we hear about containers when we talk
Mhm.
about microservices. So now we're talking about the different parts here and how they all fit together. So, explain to me what containers are and what role do we have here? How do they fit in?
Right. So I think the first thing that I need to mention here is that you do not require containers for microservices because microservices is just an architectural style which has the specifics that is mentioned out based on the distributed computing model and things like that. But in 2021, if you're building services, you're targeting cloud native apps probably, right? And you want to make use of the abundance of power that cloud provides you with. And then when you look at those cloud native technologies that you can use to make your microservices, better, that's when you start thinking in terms of containerization, right? So that's nothing but, if you look at containers, what they are is like, you package your application code, your configuration, your dependencies, including your operating system dependencies, you package them and make it into a single deployable unit, which are immutable nature. That means once I build an image, and that's called the container image. So once I build that image, that image, if it works on my local machine, it works on a test machine, it works on a QA server, and it works on the production server because they're just made that way, right? So it cannot be changed. So those advantages gives that the flexibility for the teams to choose this kind of technologies and ship things to production much faster.
Cool. So what you're saying is that I can now say to people, it works on my container, and
Yeah,
I'm gonna be good because it's gonna work on your container too, because they are immutable, and they once you define it, they don't change.
that's true.
Cool. And which brings us to Docker, because we talk about Docker when you talk about containers, and a lot of times I even might use those interchangeably. And Docker is one of those words that actually have two meanings behind it, because Docker is one, a company, but it's also an open source project too. And so we're going to talk about it as the open source project here. And what it helps you do is it helps you deploy and maintain containers that are both like on the cloud and on premise as well. And what's neat is that Docker containers, they can run anywhere, right? So like as I mentioned, whether it's going to be in your own data center or if you want to throw them up like in Azure, it can do it. And what's also neat about it here, and this is going to come in important in just a couple minutes, is that Docker containers, the image containers, they can run natively whether you're running on Linux or Windows. So really, we're kind of abstracting the operating system away. We just care about the container here. We don't really care about what it's running on any longer, at least as far as development goes. So, which is neat. So then that brings us to the next portion of things, is like kind of like the Docker architecture. And Nish, I'm hoping you can explain this to me.
Yeah. So if you look at the Docker architecture, you have the client, the host, and the registry. And registry is somewhere where you host your image, right? So you, from the client, you make a pull to the container registry, and then you bring in the image to the host where you're running your application. And when you need the scale, you basically multiply the containers. So remember I told you about container image, that's a packageable unit. And when it is running, they become containers, or in the other words, containers are nothing but the running instance of the image itself, right? And when it comes to container registry, and that's where you want to store your images so that anybody can pull it, like in terms of your production infrastructure, or in even your local development systems, right? Now there are multiple container registries there. The Docker Hub is a famous one and most publicly used one. But if you're looking for your enterprise applications, you will probably need something more secured, where your secure infrastructure can connect with a secured container registry to pull the images. And that's when you look at something like Azure Container Registry there, right? And Docker Client gives you those commands and things like that to pull, build, and run, and things like that. So which we will look at that in some time.
Okay. So cool. So an image is just really like the definition of
Yeah.
the container. The container is what happens when the image starts running, and Docker hosts is where the container runs on. Did I get that
That's
right?
correct.
All right,
Absolutely. You're
good.
perfect.
All right, good. So why would I then want to build a microservice in .NET? All right. So remember way back when .NET was just the .NET framework, we were attached to Windows only, essentially, for the most part. But then when we had .NET Core, that kind of opened us up to cross-platform where we can run anywhere. And now we've iterated, and now we have .NET 6, so again we can run it anywhere. And a nice thing about that is, as I mentioned before, is that our Docker image could be based on any kind of flavor of Linux, right? So the image itself, how we're going to define how our Docker container is, it could be based on any flavor of Linux. And because .NET is super cool now, it will run on that flavor of image. Okay, so now because we have our container that's defined to be kind of running this flavor of Linux, .NET runs there. Cool, right? So we know .NET, we can run on Linux, super cool. And now .NET super fast with like ASP.NET Kestrel, we're going to be able to run a very fast web server on Linux in a container. wow, why wouldn't we?
Anyway,
Right?
yeah, absolutely. I mean, I don't know if you noticed the demo that we put together for the keynote. We had it running the podcast app, or we had the worker services running on Azure Container Apps, which is the newest cloud native tech with Kida and Dapper and things involved in it, right? Which is nothing but kind of like a serverless Kubernetes, which based on some triggers, external sales triggers like messaging, you can scale up your deployment, and also can go scale zero by saving cost. And we were immediately able to make that happen. And all that we had it in our application was just the Docker file, because it just had instructions to containerize your image. And then rest of the thing is like, we were able to deploy it using the Kubernetes and things like that. It was very straightforward. So .NET is really, really cloud native ready. So if you're looking for applications with high performance, you should start considering .NET.
Yeah, and it's super cool. And we do, and there's big customers using .NET with microservices, cloud native first. Like Tencent uses it for their mobile payment infrastructure
Yeah,
for better
WeChat.
scalability and agility, that's super cool. I mean, they're betting their business on it. So
Yeah,
yeah.
payment services for WeChat. Basically, I don't know if you have it in the US, and we have it here in India, WhatsApp. Like, we can make payments between two chat systems. Similarly, WeChat has a similar feature, and that the payment side was implemented, the microservices way of implementing it using .NET.
Yeah. So Nish, how about we actually show
Yeah.
something? Tell us about the demo.
Yeah, let's go through the Docker file. I mean, what we're going to do is we have a learn module, and we're going to go through those independent steps, and then we will go and explain each of the steps, so that again, this is a 30-minute session, so there's limited time we can cover. But it's one thing to remember is this is also part of a large learn part. So if you're someone looking for much deeper implementation of microservices, if you start with this module, you will be able to eventually get to that, because it's part of that path. All right. So we are in the unit 3 of this module, which is the build your first microservice with .NET. And Matt, are you able to play that?
You should be going right now. Here we go.
Okay. Thanks. So this is the instructions to have .NET and Docker installed, and there is a code that you can clone from the repo there. And in this, I have it already done. And so what it has is there's a backend project, and there's also a front-end project. Ideally, in a microservice world, you'll have a bunch of microservices, but this is just a simple sample. So you have backend, front-end. The backend has a controller, nothing but a web API controller. And we have some static data out there called pizza info. So we're going to have some pizza info, send it to the endpoint when a get method is called, right? So just static data. So if you see that there's an HTTP get attribute, we have a get method, and we're just returning menu. Now, ideally, I can go ahead and run this .NET app, but what I want to do is, we should containerize this. So if you have installed Docker extensions in VS Code, then you will have this thing called add Dockerfiles to workspace. You can do Control-Shift-P or Command-Shift-P and get that. And what we have here already is a Docker file. So what we need to do is just copy those commands into this. So if you have those extensions installed, what would happen is it will automatically generate things for you. But in this case, we already have Dockerfile. So all that you need to do is just copy and paste these things. Now, these files, if you look at this, these are like commands and instructions. And so Matt, explain us what exactly this Dockerfile is.
Yeah, so we'll bring it up here so a little bit bigger. And so this Dockerfile, I mean, as you mentioned, Nish, it has the instructions to build that Docker image. And so it has like a scripting language to do so, right? And so the very first part, it's telling us how we're going to build the .NET solution. And so what we're bringing down is the SDK first, and we're calling it build. And then we're changing our working directory, and we're copying in from our local file system, the backend .cs proj, and then we're going to .NET restore it, and we're copying in the rest of the code, and then we're going to publish it. And then the second portion down there is that we are going to run it. As you see, we're bringing in the ASP.NET runtime 6.0 because we have moved to .NET 6. And then we are going to essentially say we're going to expose the latest ports, and then we are telling it where .NET should enter, and that's a backend DLL. So it's really we're doing two different things here. We're building, and then we're running. And you see right there with that copy command, right, the second to the bottom, that's where we're saying, all right, we're going to take everything that we build from above, and we're copying it into the app directory on the container itself. So yeah, that's pretty neat. Or we're copying from the app container directory. And
Right.
yeah.
Right. And just one more point there. It's a multi-stage build. And what that means is if you look at the last from statement, that's just a runtime. So since we are building everything inside the Docker, we are only copying the whatever the .NET publish command created there from the app folder. We're just copying that and having the runtime. So now you'll have your image much smaller. So
Right.
this is really great because you can even run tests and other kind of steps which is involved for you to make sure there's a efficient QA done on your image before you even release it.
Yeah. And we should say that this is being done in the container, so you don't need .NET installed on your local machine.
Right. That's true.
Which is neat. All right. And so,
cool.
Yeah, go ahead, Nish.
Yeah, so let's go ahead and just build this image. So now that we have the instruction, we may do .NET build. If you don't have .NET installed, all that you need is to run the Docker. So make sure the Docker is installed though. So go to the backend project and then run this command called Docker space build -t, which is tagging the name of the image and then specifying where exactly is your Dockerfile, which is in the current directory right now. So it'll take those instructions and it'll create those layers, and then it'll create an image for you locally. Now, if you go and type Docker space images, you will have those images listed there, which was just built 11 seconds ago. You can see that that's the pizza backend that I have there. And now we can run this. Now, to run this, there is instruction there in the learn modules. So you just copy and paste that, nothing but a Docker run command. Remember, in the client side, we showed how these the client's commands exist. And you can navigate to the port that was exposed, right? And by default, we have Swagger baked in nowadays from .NET 5.0 onwards. So you get this for free. So try it out, and then you get the same data that is listed as REST, right? So that's the JSON data that's being displayed. Now, let's talk about, so this is great. Now, what we did is we just created the image. We just created just one image, which is the backend image. Now, the next thing that we want to do is we want to work with another image as well, like work together with multiple images. So, and that's why we would need something like a Docker Compose file. So let's talk about Orchestrator, Matt.
Right. And so you can imagine once we start dealing with a bunch of different microservices, it's going to be almost a little bit difficult to handle like the how to both build them and both how to scale them and all that. And that's where an orchestrator is going to come in. And so like the de facto standard of orchestrators is called Kubernetes. And we actually have a whole other Learn module on dealing with Kubernetes. So we're not going to get in on that right now. But what we are going to call or deal with here is Docker Compose, because it comes built in with Docker Desktop. And so we can easily handle this. And so what this diagram here is showing is 6 Docker images deployed as 2 applications. And then the applications are then deployed as several clusters. And the diagram is really meant to show how difficult it would be to perform the deployment without any tools to help you. But Docker Compose can like take containers and deploy them as units of deployment. So it's going to actually take you and say, all right, all these containers, let's just deploy them as one unit, like an application. So it helps you kind of like group everything together and do it as once. So, and so like I said, Docker Compose, like Kubernetes is a big orchestrator. Docker Compose is like this is gonna be scaled down. It's a full featured orchestrator is gonna be too much for this simple website that we're dealing with, and Docker Compose gets installed with the desktop, Docker desktop that we already have. And what's neat is that Docker Compose, it runs off a YAML file itself. So Nish, how about we build one?
Yeah, let's build a Docker Compose YAML file. So let's go to the next slide. So this is a unit which will have these instructions, which is all that you need to do is just copy them and then paste it into the Docker Compose file, which is in the root folder of this project. Now, what we have here, I'll quickly explain this. Matt, yeah, thank you. So this slide will explain what exactly is a Docker Compose file, right? So if you see, there are instructions again, and we have services. You can see that there's a front end, there's a back end, right? And the way to read this is it's a YAML file, so combine the tabs and spaces. So if you indent yourself in reading them, you will get an idea about how this has been done, right? So we have a front end and a back end. Now, when we want to build a Docker image of pizza backend, we went and created Docker build and pizza backend, right? Now, compose file can also have instructions for build related as well. So that's where you'll see build : and there's a context in Dockerfile. So now you can even specify what exactly the name that you want to give, or any environment variable you want to pass in, or even the runtime instructions, right? Also, if you look at the image, the name of the image, what do we give? So there is a pizza backend in case of a backend. For a front end, there's a pizza front end, right? Now, the other thing in the environment file is the backend URL, right? Now, that's the thing, if you look at that says http://backend. Now, that's the kind of like service discovery. So if you look at the backend, the service that we're exposing, it has the name backend. So we can make that call directly to those endpoint using the name that is exposed in the services. And through environment configuration, we're actually passing this value into the configuration of our .NET Core app. And the other instruction that you may notice is the ports. There's 590280, 590080. The previously, when we built Docker build command, we explicitly, Docker run command, we explicitly mentioned the -p, and we said which is the host port and what is the internal port. The second one is the internal port, which is 80. So this is the specification that we give in order to run multiple things. So again, if you want to pull in images from Docker Hub, for example, if you want to work with the Redis cache, you want to work with SQL Server, you can provide those instructions here too, so that all of them will start running them together, and your application can start consuming it.
Cool. And we'll take a quick look at actually doing it. And you can see right here underneath environment that we are using the backend URL. And then I'm going to open up really quick here the startup, and you can see right here that in my configuration, I'm just using backend URL right here. And so this is just the front end application to grab it out. And then I'm building up the base address for my HTTP client. And then when I want to grab all the pizzas from the backend, I'm just calling it and popping it into a pizza's variable. And then when I go out, and I'm just looping through it and displaying them all in a table. So quickly, all that's happening is getting the backend URL from Kubernetes, grabbing it and displaying it. So what I'm going to run is then Docker Compose build, and then that's going to read that Docker Compose file that Nish just talked about, build everything up for me, and it takes a little bit here. But what's neat here, this next command is going to be, we're going to do Docker images. And that's going to show me 2 images. And you're going to see that the pizza backend one was built 4 minutes ago. So when we did it previously, where the other one was just built. All right, so Docker Compose up, and it's going to actually run everything. And then I'm going to go browse to it and use my new 5902 port, as Nish mentioned before, and here everything is. Super, super neat. All right, we have it all running. Both of them running at once. We did
Awesome.
it, Nish. We
Absolutely.
made it. We have 1 minute left. So we talked about what microservices were. We talked about how everything kind of fits together: images, containers, Docker Compose. We built one. We built one in microservice, or built a .NET microservice, put it in the Docker. We use Docker Compose to orchestrate it just a little bit. And again, take this Learn module at your own pace. We walk you through everything at once, aka ms.net-conf-microservice. And we have a ton of resources out here. I know, Nish, you wrote a book on this. You did a video where you walk people through this. You did a ton of work, and it's super great also. So I definitely encourage folks to learn-live microservices to check all that out. And we have a bunch of other resources on that as well there. And of course, modern web development with .NET 6 starts off, we have 5-part series going through with Hanselman and Myra lead it off, then Jeff Fritz and John Galloway come off with a couple. And then me and James at the end, we go through building your first microservice with .NET. And these are 90-minute episodes, which is great. So we're going to talk about both this one, and we're going to also talk about building with Kubernetes too. So it's going to be a little more relaxed time frame where we're going to be able to hit everything. So we have a little time for Q&A, maybe. I don't know. But anyways, yeah, that's it. Nish, thank you.
Yeah,
that was great.
Yeah, that was great. So Brady and Katie, are you coming in?
Awesome questions, guys. So keep asking those. The first one is from Diego, and he's asking, would you recommend Azure Functions to deploy microservices instead of containers?
It depends, actually. I mean, if Azure Functions are great for microservices and scenarios like that, if you have scenarios where there are Kubernetes environment and you want to do more of those things, like working with Redis caches or other kind of dependency that you will need in containers, you can use containers, Kubernetes, and things like that. But yeah, totally okay to build with Azure Functions.
Cool. And then there was one other one. Is this one down here? Oh,
So another quick question, because this one was so good, from Cameron. Cameron, I'm hoping I'm pronouncing that correctly. How accurate is the use of a single database in microservice?
I'm not sure if I understand that question, Matt. What do you mean by use of single database in a microservice?
like maybe is that a pretty standard convention? Is that like something a lot of folks do? Like I think maybe that's the point of that question.
You probably could, but I'm not sure if you want to. I guess
Okay.
would you say that, Nish?
Yeah, I mean, the question is if to use a single database for multiple microservices to work together, then I think that defeats the whole microservices pattern.
Think so? Okay.
So that would, because then you will have the bottleneck, the same thing that we talk about, right? So we do use shared databases in some occurrences, but that's kind of like depending on the situations.
Got it. Makes sense. Well, thank y'all so much for introducing the concept of doing microservices with .NET. I would definitely encourage everybody to take a look at those Learn modules and the other resources that Nish and the team have put out. Now we're going to say goodbye to Nish and Matt. Nice to see y'all.